enough.
I don't even have the thing. There's something about
All right, rational zero theorem, 3.4, or zeros of polynomials. We're going to do the rational zero theorem. Okay, so bear with me because there are a couple typos, right? So let f of x equals a sub n x to the n power plus a sub n minus 1 x to the n minus 1 dot dot dot. So this is a polynomial, n is whole numbers, and you have integer coefficients. What's an integer again? Whole number, good. Negative or positive whole number. Then the only possible rational, what's rational? What's a rational number?
Is the little n right there? So it's like a and then the little n x.
Yes.
And then the n, okay.
Just like the previous, when we defined what a polynomial is, it should be the same. It's a sub n x to the n.
Okay.
It's just a way to keep track of a's. A sub n goes with x to the n. A sub n minus 1 goes with x to the n. Those are just numbers, right? Possible rational zeros are factors of a sub 0 over a sub n. A sub 0 in this case is the constant. It's the number with no x's, right? A sub n is the lead coefficient. It's next to the variable to the highest power, right? So those are the only possible rational zeros that we can have that can possibly be roots. Okay? What's rational again? Did you guys answer that? What's a rational number? Oh, it's a fraction.
Oh, is it a fraction?
Yeah, a rational number is a fraction. Okay, so let's do the first one. F of x, I'm going to change it, is x to the fourth plus x to the third minus 3x squared minus 5x minus 2. Okay, so it says use the remainder and factor theorem to determine all zeros of the following. So we're going to use the rational zero theorem to determine what rational numbers we should even consider, right? We don't want to choose any possible rational number. We're going to use this theorem to determine what values we should even consider, okay? So we want to look at factors of negative 2 over factors of 1. So what are factors of negative 2? Plus or minus 2, plus or minus 1, right? Factors of 1 are plus or minus 1. So we need to do factors of these divided by factors of these. So we have plus or minus 2. So it's 2 over 1 and 1 over 1, right? Plus or minus, plus or minus, plus or minus, right? 2 over 1, 1 over 1. So it's plus or minus 2, plus or minus 1. So now I'm using those previous theorems that we just did to see if the remainder is 0, right? Use the remainder theorem. If the remainder is 0, I plug it into the function. If the answer is 0, that's the remainder. That means that it is a root, it is a factor, right? So now I'm kind of putting these ideas together. So I need f of 2, f of negative 2, f of 1, f of negative 1. So f of 2, I'm going to my original function. Wherever I see an x, I'm putting 2. Where'd I get what?
The factors, where'd you put those in the first place?
Okay, so I'm looking at factors of a naught over a sub n. A naught is the coefficient, it's the last number.
Okay.
So that's my 2. Over factors of a sub n. A sub n is the lead coefficient, which in this case is next to x to the fourth, which is 1.
Okay.
So all of those factors. So then I'm making them fractions, right? Factors of these over factors of these. Because the lead coefficient is 1, it just ends up being the same thing that I had. So minus 3 times 2 squared minus 5 times 2 minus 2. What does that equal? Negative 8. I did it in my head. So what does that mean? The remainder is negative 8. So it's not a factor, not a root. Good. Not a root, not a factor. What'd you get for f of negative 2? 0, me too. So what does that mean? So that means x equals negative 2 is a root, which means x plus 2 is a factor. Right? Okay, what about f of 1? Oh, no. Sorry, I mixed these up. F of 2. Oh, shoot. F of 2 is 0. F of negative 2, sorry. Ah, shoot. It looks ugly now. That means that, oh, look. So good. These are the correct calculations. I'm sorry. I copied them down wrong. So this is what we get for our answers. Sorry, I made a mistake, y'all. I'm trying to go fast, and that leads to more mistakes. Actually, we have 2 more minutes. My watch didn't go off yet. Thanks, Dante. All right, so write this down. We'll start with number 2 next time. Again, I think I uploaded my rough draft of the notes on Canvas, so we will be crossing some stuff out. So let's summarize. So I have this rational zero theorem tells me what rational numbers to look at, because I could look at anything, right? But these are the only rational numbers I need to consider. Once I plug them into my function, the result is the remainder. If the remainder is 0, it is a root, it is a factor. So we're combining 3 theorems now, so we need to have a good idea of what those are, right?